If I recall, this is where we left off last time. Okay, so if you recall, the method that we used to determine RTH, okay, what we did was to determine RTH. If this is my network, so these are my load terminals. Okay. To determine RTH, with respect to the load terminals, we get the equivalent resistance, no? Okay. With all independent sources suppressed. Okay, yun yung technique na ginamit natin to determine RTH, no? And it's easy to suppress an independent source. A voltage source you replace with a short circuit, a current source you replace with an open circuit. But I want to emphasize that this will only work if the network contains only independent sources. Let's do another quick example, no, just to refresh you. So this is an example of a circuit with an independent source. So the problem is find V of O using Thevenin's theorem. So we're supposed to find this voltage. Okay, so ano yung ginawa nating strategy? We consider the 1K ohm to be the load and we take it out. So you consider 1K ohm to be the load. Remove the load, no? Remove the load. Okay. So ang matitira sa atin, if we do that, you have your 9-volt source, 300 ohms, 600 ohms, 10 MA, 300 ohms. Yung 1K ngayon, tinanggal na natin. $500 ohms. Okay, there are two things we need. We need to determine the Thevenin voltage. And we also need to determine the Thevenin resistance. Unahin natin yung Thevenin resistance. No? So with respect to the load terminals, with respect to these terminals, what is the equivalent resistance of the circuit with all independent sources suppressed, no? Or with all independent sources reduced to zero. No? So to get RTH, what is my circuit going to be? Yung 9-volt ko, short circuit na. So 600, 300, 300. Okay. Ano mangyayari dun sa current source ko? No? Yung current source ko will be an open circuit. So ito magiging hanging. This will be hanging. Kung hanging siya, pwede na nating tanggalin, no? So with respect to the load terminals, so these are my load terminals, ano ang RTH ko? No? RTH is looking into these terminals. This is now simply equal to 300 in parallel with 600. So these two are in parallel. Plus 300. No? So what's the value of this? This is 200 plus 300. This is 500 ohms. Okay. RTH is equal to 500 ohms. Okay. So half the problem is already solved. No? So what's the second half of the problem? The second half of the problem is to get VTH. Okay, ito yung VTH natin, ano? VTH is the open circuit voltage. Sorry about that. VTH is the open circuit voltage here, no? That is VTH. Note that, well, ang una mong siguro gagawing approach to determine VTH is what you're used to. No? Sanay ka na siguro sa nodal analysis, yes. You can use nodal analysis to get VTH, no? So you can get VTH through nodal analysis. So maybe you can make this your reference node and then you apply KCL here, no? KCL, but you also would have to apply KCL here. So you come up with two equations in two unknowns. Note that usually you use nodal analysis when you want to compute for many quantities in your circuit. But in this particular case, we only want to compute for VTH. So another strategy would be to try to simplify the remainder of the circuit. And we can do that using network simplification. So how can we do that? For example, itong 9 volts in series with 600 ohms, I can convert that to a current source. Mag-advance yung slide ko. Okay, so the 9 volts in series with the 9 volts in series with the 600 ohms, I can convert that to a current source. So what is the value of the current source? It's 9 divided by 600. So this is 9 divided by 600. And then this will be 600. So this is now going to be parallel to a 300 ohm, no? Parallel to this. And then let's put in all the others. No? So this is 300. I have this 10 MA. Then I have my 600. I'm trying to determine VTH. Sorry, 500 pala to, 500. Now what happens is, itong dalawa naka-parallel ngayon, ano? So the parallel combination of that is 200. So my next iteration, I'll have 9 over 600, 200, 300. This is my VTH. My 10 MA and my 500. Ito, pwede kong ibalik ulit sa voltage source. Okay. So what will be the voltage source equivalent of this? This is going to be 200. And then I have minus plus. This will be 9 times 200 over 600. No? So what's that? 9 times 1800 over 600. So this is 3. This is going to be 3 volts. Yeah. Okay. Just wanted to make sure I don't make a silly mistake. No. So again, if I redraw, I will have 300 here. I'll have my 200 here. I'll have 3 volts, 10 MA, and 500. And I'm trying to determine VTH. So now you see that it's quite easy to determine VTH. I know the current flowing through my loop that is dictated by my current source. So I can get the voltage across my 200 ohms. I can get the voltage across my 300 ohms. And then I can do a KVL here. I can do a KVL there. Okay. So in effect, what do I have? I have VTH is equal to 3 volts plus 10 MA multiplied by 200 plus 300. Okay. So this is 3 volts plus, that's 10 times 0.5, which is equal to 5 volts. 5 volts, 8 volts. VTH is equal to 8 volts. So ano yung equivalent circuit ko with ano yung Thevenin equivalent ko? I'll have an 8 volt source. And then what is my Thevenin resistance? That is 500 ohms. So I have my 500 ohms. My original problem, I wanted to compute for V sub O. So what do? I put back the 1K. Ibabalik ko rito yung 1K. Put the load back. And now I can get V sub O by voltage division. V sub O will be 8 volts multiplied by 1K over 1.5K. So 8 divided by 8 times 1K over 1.5K. Okay, so that's 5.33 volts. So please try that again on your own. You could have done that using Norton's theorem. If you did that using Norton's theorem, what you needed to get is the short circuit current here. To get Thevenin, to get the Norton resistance, it's the same as the Thevenin resistance. But what you would have had to do was to get the short circuit current here. Actually, here, pwede mong kunin yung short circuit current dito, for example, because this is still the same. This is still the same circuit. So try this on your own, Yung use Norton's theorem to find V sub O. Okay, so what if the network contains both independent and dependent sources? Pag yung network natin may both independent and dependent sources, hindi na pwede yung technique na ginawa natin kanina. So this is the method, let's call it method 2 for determining Rph. You remove the load, you get the open circuit voltage, you get the short circuit current, and Rph is equal to VOC over ISC, which is the same as VTH over I sub n. So very quickly, let's go into an example. So my problem is to get I sub x. I want to use Norton's theorem to get I sub x. Yeah, I want to use Norton's theorem to get I sub x. So let me treat my 125 ohm resistor as my load. So ang una kong gagawin, tatanggalin ko yung load, So this is the load. So remove the load. Ano matitira? Is V sub x over 400. Is 400. 300. 10 volts. 100 ohms. Okay, this is V sub x. This is V sub x. So these are now my load terminals. Itong dalawang terminals na to are my load terminals. So ano yung sabi ng procedure natin? I have to get the Thevenin voltage, the Thevenin current, and my Thevenin resistance would be the ratio of the Thevenin voltage to the Thevenin current. Okay. So unahin natin yung Thevenin voltage. What is my Thevenin voltage? Notice that my open circuit voltage here is also equal to V sub x. So what I have to do is I have to compute for V sub x. Okay. Now there are many, you now have many tools for doing this. Let's go back to the tool that we are supposed to be very familiar with at this point. No? Ang gamitin nating tool is the node voltage method. No? So let me call this my reference node. Okay. Note that if that is my reference node, this voltage is also going to be V sub x. This voltage V sub x will be this voltage V sub x because this is my reference node. So let me call this voltage now V sub y. Okay. I need to identify this particular voltage here. Okay. This voltage is V sub y plus 10 volts. Itong voltage na to is V sub y plus 10 volts. Note that if you consider this voltage to be V sub z, then V sub z minus V sub y should be equal to 10 volts. And that's why V sub z is V sub y plus 10 volts. So applying now KCL to this point, if I apply KCL to this point, okay, what is my KCL equation? I have V sub x over 200, okay, plus V sub x minus, okay, the voltage here minus the voltage here. But what is the voltage here? That's V sub y plus 10. This is over 100. I only have two currents, no? The current going down here and the current going to the left here. So this should be equal to 0. Okay, I have a question for you, and please shout out an answer. Can I apply KCL here? Yes or no? Can someone shout out an answer? Nakalimutan na ba ninyo yung nodal analysis? Can I apply KCL here? I guess no one seems to want to venture this.
Sir, yes po, pwede. Kasi wala naman po ibang variable na madadagdag.
Wala. Thank you for attempting to answer, Ivan. Ano? Wala ka bang nakikitang problema kung mag-KCL ako rito? Okay, may sagot si Peter. Peter, can you tell everybody your answer? Nahiya yata si Peter. Okay. Actually, you can, but if you do, you're going to introduce a new variable, no? You're going to introduce a new variable because you don't know the current flowing through your voltage source. No? Now notice that this is what? This is a floating voltage source. So dapat magki-KCL ka sa supernode. So this is actually a supernode. So what is my Kcl equation for the supernode? I have this current coming into my supernode, negative because it's entering. So that's minus Vx over 400. I have this current going down. That's Vy over 300. Okay. And then I have this current that's going to the right. But what is this current? That's Vy plus 10 minus Vx over 100. And that will give me 0. So I have two equations, two unknowns. I can solve for Vx, which is VTH. Unfortunately, I solved this earlier, but I lost the sheet of paper where I put down the answer. So just try doing this on your own para ma-compute nyo yung VTH. So that you can compute for VTH. Okay, so don't forget the concept of a supernode. If you wanted to do a KCL here, it's okay, except that magde-define ka ng bagong variable. Okay, so that's one half of getting the Thevenin resistance. How do I compute the Thevenin resistance? I also need to know the short circuit current that will flow through here. That one is a little bit easier. Let's see. Sorry. Yeah, it's current source, no? This is current source. So Vx over 400, 300. Then 100, 200. Okay, so these are my load terminals. Let me just check. No, that okay. So what is the next thing that I have to do? I have to short this and get the value of ISC, which is equal to I sub n. If I short this, what is the value of V sub x? Anyone? Ano nagiging value of V sub x? 0, right? Because the voltage across any short is equal to 0. That's right, Patrick. No? So if V sub x is equal to 0, itong current na to will also be equal to 0. In effect, this becomes an open circuit. That becomes an open circuit. So ang natitira na lang na circuit ko will be my 300 is 10 volts. This is 100. And this is my short circuit. ISC, which is equal to IN. Ano nangyari sa 200? Since my 200 ohm resistance is shorted out, there will be no current that will flow through it. So I can take it out. No? All the current, lahat ng current na nanggagaling dito, walang bababa rito. Lahat pupunta dito sa short. No? Remember that what I said was a short circuit is like a single point. In other words, it absorbs the 200 ohm resistance within it. So it's now very easy for me to compute for Is of n. Is of n is just now equal to 10 over 300 plus 100. Okay, so this is 1 over 40 amperes. So finally, Rph, pasensya na hindi ko na-compute yung VTH, ano? But we can solve for VTH. So Rth is just now going to be VTH over Is of n. So solve na yan. So the next step, okay, you now have your Norton equivalent, Is of n, and then you also have Rs of n, which we computed for here. Sorry, no, wala pala, no. Yeah, Rs of n, which computed for here. No? This is equal to Rth is also equal to Rs of n, no. Ibabalik ngayon natin yung load, which is 125. So this is now what we're computing for Is of x. Okay. So dapat masosolve na nyo for Is of x. So just complete the computations on your own. No? I already outlined exactly how you're supposed to do this. Okay, now this is the third case. What if the network contains only dependent sources? So ang unang case natin, the network contained only independent sources. The second case was the network contained both independent and dependent sources. Now the third case is, what if the network contains only dependent sources? Kapag walang independent source ang network natin, automatically our Thevenin voltage and our Thevenin current will be equal to 0 because there's nothing that will provide power to the network. No? There's nothing that will provide power. Remember that the dependent sources will depend on voltages and currents established by independent sources. Okay, so how do we compute for the Thevenin resistance? What we do is, okay, according to the procedure, we connect a test voltage, V of t. We determine the current that will flow, and the Thevenin resistance is the ratio of the voltage and the current. Instead of a test voltage, you can use a test current. So the best way for me to illustrate this is by means of an example. So this is my example. Notice that this circuit, okay, tinanggal na yung load, ano? Wala na yung load. So presumably, these are your load terminals, and you want to know the Thevenin equivalent of this circuit. So the circuit has no independent sources. If you try to solve for the value of VTH or V open circuit, no? Try to solve for this V open circuit. Now you're going to get V open circuit is equal to 0. So if you're not convinced, apply all the techniques that you know to determine itong VOC, and you're going to see that VOC is equal to 0. No? Meaning to say, the Thevenin voltage is equal to 0. Ganon din, ano? If I short this, and I try to get the value of ISC, I'm going to get ISC is equal to 0. Okay. So okay. So how do I determine now the Thevenin resistance? No? Two ways. One is using a test voltage, the other is using a test current. So kunwari maglagay tayo ng test voltage. So let me put a test voltage here. And to make things easy, I can assign any value to this. Let me assign 1 volt. Now what I have to do is I have to compute for the test current that will flow. So how can I do that? Again, ang gamitin nating technique, which you should be very familiar with now, is nodal analysis. So this is a super node. This is a super node. Let me call this voltage, tawagin na lang natin itong V of X. No? V of X. And then, well, V of X, no? Because may X terminal tayo. Let me call it V of A, no? Let me call this V of A. Okay, what is my supernode equation? I V of A over 20 plus V of A over 40. Okay, plus, I'm assuming this is my reference. What is the voltage at this point? The voltage at this point, the voltage at this point is equal to 1 volt. Okay, so this is 1 volt, 1 over 20. Okay, minus, well, I don't know the current being supplied by this. But that's actually what I want to find out. Yun yung hinahanap ko. So let me make that a variable. No? So the current I assume to be entering, so that's minus IT is equal to 0. So that's my one equation. Okay. I'll ask you, what is my other equation? Because I have two unknowns here. My unknowns here are V's of A and I's of T. What's my other equation? Ano yung pag supernode, no? Ano yung second equation that you need? It should be related to the supernode. Anyone, please shout out.
Sir, ano po? V of A minus 1 is equal to 20 IX.
Very good, yeah. So the other equation is V of A minus 1 is equal to 20 times IX. But what is IX? I of X is V of A over 40. No? So this is 20 multiplied by V of A over 40. Okay. So matter of fact, mula rito, masasolve ko na yung V of A no? Dito, sa equation na to. V of A minus 1 is equal to 1/2 V of A. So 1/2 V of A is equal to 1. So V of A will be equal to 2 volts. Okay. Let me just check my notes. Yeah, V of A is equal to 2 volts. So if I plug this back here, okay, is of t is equal to 2 over 20 plus 2 over 40 plus 1 over 20. So 220, 4 plus 1, 5. Okay. So anyway, V's of A sige, let's do it step by step para hindi magkamali, ano? So 2 over 20 plus 2 over 40 plus 1 over 20 is equal to is of t. No? So this is 4 plus 2, 6 plus 1, 7 over 40. Tama ba? Yeah. Eight over 40. No? Is of t is equal to 8 over 40, which is equal to 1/5 ampere. Okay. So ano yung magiging RTH natin? RTH is equal to V's of t over I's of t. So this is 1 divided by 1/5, so this is just 5 ohms. Meaning to say that this circuit is just equivalent to a resistor that is equal to 5 ohms. Okay. So that's how you deal with circuits with dependent sources only. Now, the other technique dito, I could have used a test current instead of a test voltage, no? In which case, dito sa XY, this is X, this is Y. I would have put a current source, okay, Is of t. Let's say you say, palagay na natin ng 1 ampere para mapadali. And what I have to compute for would be my V's of t. So if I put a current source here instead of a voltage source, and then what I compute for is V's of t, I'm going to get RTH will be V's of t over I's of t. And I should get exactly the same value. Any questions? Okay, I just wanted to summarize, no? How do we find RTH? So 3 cases. Network has independent sources only. Network has independent and dependent sources, or network has dependent sources only. The easiest method is the method of the first method that we learned, but you can only apply that for this first case. The second method that we learned, where you get the open circuit voltage divided by the short circuit current, you can apply that to both these 2 cases. And the last method that we learned, which is the only method available if your circuit has dependent sources only, you can actually use for all 3 cases. But if you use the third method for either case 1 or case 2, then you have to do this step. You have to zero out all independent sources. You have to do that step if you use this particular method, method 3, for these 2 cases. Any questions? I have to talk about one topic. No? Teka, may question from Patrick. Why is VTH 0 sa example? You're talking about this, Patrick? Patrick, can you speak up? Ito ba dito sa example na to?
Opo, sir.
Kahit na anong gawin mo, no? Compute mo na lang yung VTH, no? Compute mo yung VTH and you're going to get 0. Kasi wala kang source dito eh, no? The only thing you have here is a dependent source. The dependent source depends on this particular current. But what is going to generate this current? You need an independent source to generate that current. In other words, chicken and egg problem. Your dependent source can only generate a voltage or can only generate a current if there's another voltage or current existing in the circuit. But if you don't have any independent sources, you will not have any voltages or currents existing in the circuit. So you have a chicken and egg problem. So lumalabas automatically, VTH will be equal to 0. But if you don't believe that, get this circuit, kunin mo itong original circuit, computein mo yung open circuit voltage, and you're just going to get the open circuit voltage is equal to 0. So try it on your own.
Salamat po, sir.
Okay, thank you. So ito yung kailangan ko i-discuss sa inyo, no? Maximum power transfer. No? Maximum power is delivered to a load R if R is equal to the Thevenin resistance seen at the terminals of R. In other words, if I have a circuit, and this is my load, no? The value of the load is R. Okay. Maximum power will be delivered to R if R is equal to RTH. RTH is the Thevenin resistance looking into the terminals of R. Okay, no? Let me replace this with its Thevenin equivalent, no? So ang Thevenin equivalent ng circuit natin, you're going to have a VTH and you're going to have an RTH. This is my circuit. Tapos ang nakakabit dito is R. So ano yung current dito? What is I? I will be equal to VTH over RTH plus R. What is the power delivered to R? So piece of R is equal to I squared times R. So that is VTH over RTH plus R squared multiplied by R. Let's try to plot that. No? Let's try to plot that. Piece of R versus R. When R is equal to 0, piece of R will also be equal to 0. No? Kung 0 itong value na to, itong piece of R will also be equal to 0. Now, when R is equal to infinity, if R is equal to infinity, this value will tend to become 0, right? And the product of this multiplied by this, even if this is increasing, this will be increasing faster, or this will be decreasing faster. The product of that will tend to become 0. No? If you don't believe, use your calculus. You try to get the limit of this quantity as R approaches infinity, and you're going to get 0. So if I plot piece of R versus R, my plot is going to be something like this. So there's a maximum. So this is my maximum power. And that happens when R is equal to RTH. Let me add this slide now. Okay. So take a simple example. Let's say, okay. Ito yung sa example natin kanina, no? Let's say this is my Thevenin equivalent. And I connect here a resistor R. So question, no? What is the maximum power that R can absorb? So can I ask you to try to solve this? I'll give you a minute, please. What is the maximum power that R can absorb? That should be very easy for you to determine based on what I just said. Anyone? Bring out your calculators and please try to solve the problem. Wala. Come on, guys.
0.032 po.
Point. Who answered that? Yeah,
0.032.
that's correct, no? The maximum is watts or 32 milliwatts, no? If we want to use engineering notation, it should be 32 milliwatts. Okay. So very easy, no? At what value of R will maximum power be transferred to it? The value of R should be equal to 500, no? So maximum power will happen if R is equal to 500. This happens when R is equal to 500. So you can easily compute for I. I is just 8 divided by 500 plus 500. And so P is equal to I squared times 500. And you're going to get 0.32 watts. Okay, bakit importante ito? This is very important. This has a lot of practical applications in electrical systems. I'll give you an example of maybe something that I don't know if you're fond of audio systems. Let's say you have an audio amplifier. So saan mo kinakabit yung output ng audio amplifier? Kinakabit mo sa speaker. Itong audio amplifier na to, looking into the speaker terminals, meron niyang RTH. No? That has a Thevenin resistance. And your speaker also has a resistance, no? R speaker. Okay, if our speaker is not equal to RTH, then you don't get maximum power delivered to the speaker. In other words, yung lalabas sa speaker nyo, mahina. No? Typically, ang value ng RTH ng audio amplifier, this is typically from 4 ohms to 8 ohms. No? So, dapat, yung speaker na ilalagay nyo, dapat ganun din, no? 4 ohms to 8 ohms. Kung ang kinabit nyo dito, yung headset nyo, okay, siguro halos wala kayong marinig dun sa headset nyo because your headset is a very high resistance. If it is a very high resistance, then you're not going to get any appreciable power delivered to it, and you're not going to hear anything. No. On the other hand, if you try to plug your speaker into the headset jack of your phone, let's say, no, usually nakikinig kayo siguro ng music using your headset, and now you want to try to plug a speaker, maybe nothing will come out of the speaker, or some very, very faint sound will come out of the speaker. No? Because your headset has a very high resistance. It was designed to match to the resistance of your computer or to the resistance of your phone. So pag nagplug kayo ng speaker, hindi na ngayon magiging matched. No? So this is what you call resistance matching. No? Maybe another example. Another example is your TV and your Digibox. Kung meron kayong Sky Cable, meron kayong Digibox, yung output, yung Thevenin resistance ng output ng Digibox, dapat nakamatch yan sa input resistance ng TV. So that from the Digibox to your TV, you get maximum power transfer. No? So meron kang Digibox, meron kang TV. Ito may RTH to. Ito meron din tong input resistance. No? For maximum power, dapat match yan. No? As far as I know, the resistance of the cable input to your TV, this is assuming naka-cable ka pa, hindi pa to the HDMI, no? So, kunwari yung mga lumang Digibox, ano? The cable input to your TV, I think, is 75 ohms, and that's also the output of your Digibox. No? Now, what happens if you decide to connect a second TV? Ilalagay lang nyo dito. No? Hindi na magiging matched. Now you'll have two TVs in parallel. So magbabago na yung R-in mo. It will no longer be matched. So your Digibox will not be able to deliver maximum power now to your TVs. So that's what you call resistance matching. So that's something that is very important. Any question with regard to that? Okay, so I hope I was able to provide you some insight there. Okay, we have another topic to take up, and that is superposition. So if there are no more questions with respect to Thevenin's and Norton's theorem, so we took up Thevenin's theorem, Norton's theorem, we took up source transformation, we took up maximum power transfer. We'll now go into superposition. So let me pick up the presentation. So this is another very important network theorem. Okay. Please bear with me, mag-overtime tayo ng konti. I wanted to finish by 3:45, but we'll probably have to take up all of the time. So this is a very important network theorem, superposition. So this is the principle of superposition in a linear electric circuit. Again, don't worry first that you don't know what the meaning of linear is. You're going to find out soon enough. In a linear electric circuit containing n independent sources, the current or voltage in any branch is equal to the algebraic sum of n components, each of which is due to each independent source acting alone. So what does that mean? Well, to put it simply, supposing I have a network, I have n sources, and independent sources, and independent sources. We're talking about independent sources here. And let's say I have a current flowing here. I have a current flowing here, I. Okay. What superposition says is that I is equal to I1 plus I2 all the way to plus IN. No? Where this is source 1, this is the current with source 1 acting alone. And this is the current with source 2 acting alone. And so forth. No? This is source N acting alone. So if I have n independent sources in my circuit, if I compute for the individual currents with the sources acting alone and add them all up, I will get the total current. And that applies not only to currents, that also applies to voltages. Now, how do you make a source act alone? We already took that up last time. If it is a voltage source, you remove the source and you replace it with a short circuit. Sorry that I messed up the slide. If it is a current source, you remove the source and you replace it with an open circuit. So we already know that from last time. No? So best to explain this through an example. So this is the problem. Okay, find I1 and I2 using nodal analysis. No? So yung purpose nito is so that we can compare the answer later on to using superposition. But dapat madali na to sa inyo, no? Using nodal analysis, how do you determine I1 and I2? Well, you have one node, no? This is your reference. So you apply KCL here. So what is this? This is Vx minus Vs over R1 plus Vx over R2 minus Is is equal to 0. No? So presumably, these are all given. Presumably this is the only unknown. No? This is my unknown. So these are all given, Vs, R1, R2, and Is. So I should be able to solve for Vx. So I can solve for Vx. And then I1 is just Vs minus Vx over R1. And I2 is equal to Vx over R2. Okay. So you can do this on your own. Let's not go through the details of that anymore. That's what we've been doing since I guess since last week, you know. So now what I want you to try is how do you solve this using superposition? So if you want to solve this using superposition, we compute for I1 and I2 with Vs acting alone. And then you compute for I1 and I2 with Is acting alone. And my I1 now will be the sum of the components contributed by both Vs and Is, and so with I2. No? So first, let's take a look at V sub S acting alone. With V sub S acting alone, okay, let me call this now I1A and I1 and I2A. No? That's because yung I1 natin is the total current. No? So this is just contributed by V sub S. I1A is equal to I2A, which is just equal to V sub S over R1 plus R2. No? Note that we only have one current that will flow through this circuit. That current is I1A, which is equal to I2A. Now, if we assume now that IS is acting alone, so dito V sub S is acting alone, so we replace IS with an open circuit. Here it is IS acting alone, so we replace VS with a short circuit. It's now very easy to get I1B and I2B. No, we can use current division. So using current division, yung I2B, that's easy, no? That's IS multiplied by R1 over R1 plus R2. This current, pababa, is this current multiplied by R1 over R1 plus R2. And I1B, okay, note now that this is negative because the actual direction of current will be this way. No? This is the actual direction. Remember, this is current division. So itong IS na to, pagdating dito, we'll split one component going this way, the other component going this way. That's why I1B is negative. So there's going to be IS multiplied by R2 over R1 plus R2. So that's how you use superposition. No? Ang value ngayon ng I1 is equal to I1A plus I1B, and I2 will be equal to I2A plus I2B. So try this. No? Try computing for I1 and I2 using this method. And then try to compare it to what you will get using superposition. You should get exactly the same results. So I leave it up to you to try that. Okay, so here we just make the example a little bit more difficult. This time we have three sources. You have your 81 volt source, you have your 6 ampere source, and you have your 9 ampere source. So for any current in any resistance, it will be due to three components. A component due to the 81 volt source, a component due to the 6 ampere source, and a component due to the 9 ampere source. So if the problem is find all currents using superposition, then we have to compute for all currents contributed by each of the sources acting alone. So sorry, I forgot to erase this. No? Yeah. So for example, the 81 volt source acting alone, so this one acting alone. So pag ganyan, ano mangyayari? Ito magiging open circuit, ito magiging open circuit din. So ang matitirang circuit, ito lang. This is what will have. This is what will be left. No? If you notice, IA, let's call this IA, the current that will flow here, is just 81 divided by 6 plus 12 plus 3 plus 6. And then if we consider the 9 ampere source acting alone, then the 81 volt source is a short circuit, and the other current source here is an open circuit. And so now I can use current division to compute for IB and IC. And these are going to be my current divider formulas. IB is equal to 9 9 multiplied by 12 plus 3 over 12 plus 3 plus 6 plus 6. And IC would be 9 multiplied by 6 plus 6 over 12 plus 3 plus 6 plus 6. Finally, if I consider the 6 ampere source acting alone, so this becomes an open circuit, and this is a short circuit, again, I can use current division. ID is equal to 6 multiplied by 3 plus 6 over 3 plus 6 plus 6 plus 12. And finally, IE will be 6 multiplied by 6 plus 12 over 3 plus 6 plus 6 plus 12. So I now have all the currents in all the resistors contributed by each source acting alone. So to get the current in any resistor, we can apply superposition. So for example, if I want to get the current in the 3 ohm resistor, what are the currents that flow in the 3 ohm resistor? Let's go back. No, you have IA flowing downward in the 3 ohm resistor. I have IC flowing downward in the 3 ohm resistor here, and here I have IE also flowing downward in the 3 ohm resistor. No? So the current in my 3 ohm resistor will be, sorry about this, I 3 ohms will be IA plus IC plus IE. No? Let me just check. IA, IC, and IE. Yeah, that's right. No? Okay, so superposition. Okay, here, let's make it a little bit more difficult. Lalagyan ko ng controlled source. So I want to use superposition to determine the current I, but this time I have a controlled source. So note that I have only 2 independent sources. And therefore, my controlled source has to have 2 components. I will consist of 2 components. One, due to the 4-volt source, and the other, due to the 2 ampere source. I don't consider I due to the 5Vx source because this is a dependent source. By itself, this will have no contribution to the current I. Remember that your dependent source relies on voltages and currents that are generated by your independent sources. So this will have no contribution to the current I. No? So how do we solve this problem? So first, we consider the 4-volt source acting alone. So if this is acting alone, this becomes an open circuit, naging yung 1 ohm, and so we can take it out. And now you can see that I just have 1 KVL loop here. So let me call the component of A contributed by the 4-volt source. Let me call that I of A. So it's now very easy to compute for I of A. I do a KVL here. What is my KVL there? I have Vx minus 2 plus, so that's negative, plus 4, plus 3IA, plus 5Vx is equal to 0. So this is my KVL. But Vx, notice that Vx is equal to minus IA times 2. This is IA. IA should produce a positive voltage here with respect to here, but Vx has opposite polarity, and that's why it's a negative sign. So combining these two, I can solve for IA. I can solve for IA. Do I have the solution of that? Unfortunately, just solve for that, no? Kasi nagmamadali na tayo. Now I consider the 2 ampere source acting alone. So I take out the 4 volt source. I replace it with the short circuit. So ito na yung 4 volt source replaced with a short circuit. How do I compute now for the current I contributed by the 2 ampere source? When all else fails, do nodal analysis. So let me make this my reference node. The voltage here will be Vx. So what is my node equation? My node equation is Vx over 2. Okay, minus 2 amperes. 2 amperes is the current flowing into Vx. Okay, what about this current flowing out? This is going to be plus Vx minus 5Vx over 3, and that should give me 0. So I can solve for Vx. What is IB? IB will just be Vx minus 5Vx all over 3. So I can also now solve for IB. And so I will just be equal to IA plus IB. Again, I'm just outlining the solution. Please do this on your own. There are several additional exercises in the notes, so please try them. The one I want you to particularly try is this. This is a little bit challenging. If you attempt to solve this and you want me to check it, then submit your solution to me and I'll tell you whether you're doing it correctly or not. But this is challenging because you have 2 controlled sources and 2 independent sources. So having 2 independent sources, you only have 2 components of voltages or currents at any resistor. There will only be a contribution due to the 10 volt source and due to the 5 ampere source. So you take the 10 volt acting independently, you take the 5 ampere acting independently, you add the 2, and that should allow you to solve for V sub O. So I'm going to stop there. Well, this is the equivalent circuit with the 5 ampere source suppressed, and this is the equivalent circuit with the 10 volt source suppressed, and this will give you the value. The value is 24 volts, that is of V sub O. But the solution, I leave that up to you. If you're not getting the correct value, 24 volts, you can show me your solution. I'll tell you where you're doing wrong. So that's the last slide I have. Medyo napabilis yung discussion natin sa superposition, but hopefully I was able to teach you the essence of it. There's a lot of material that is published in UVLE, a lot of resources. So this is really only supplementary. There are lecture videos, there are YouTube videos that you can look. This is for all of the topics that was discussed dito sa week 4. No, week 4 na ba tayo? Yeah, that's right. Dito sa week 4. The recording of this lecture, I'm going to send it again through UVLE, and I will also send you annotated slides. I just have to correct the slides because there's some incompatibility between my PowerPoint in my iPad and the slides that I have. Any questions before I let you go? Medyo tahimik ngayon yung klase. I hope you didn't get overwhelmed by what we took up today. So no questions? Okay, so I guess that's it for today. So, okay, that's all. Thank you.